Hi friends, welcome back to new session. In the last session we discussed about field winding, which is a part of, I can say, field magnet and armature core, and we explained about commutator also in a construction of DC machine. Okay, so what was the conclusion in a previous session? So if you see field winding, so generally field winding will be connected to armature. Okay, suppose if it is series machine, field winding will be connected in series with armature, and if it is shunt machine, field winding will be connected in shunt or in parallel with armature. Suppose series machine, series field winding resistance value is very less, around 1 ohm, and in shunt machine, shunt field winding resistance will be large, around 100 to 200 ohms. And if you compare number of turns, series field winding number of turns will be lesser than shunt field winding number of turns. And if you compare MMFs, shunt field winding MMF is more than series field winding MMF. That was the conclusion regarding a field winding. And if you see armature core, armature core accommodate armature winding. Nothing but in that armature core will be having some slots. In that slots you have to place armature winding. Is it clear? That means armature core accommodate armature winding. And I told one more thing. Armature core is laminated to reduce eddy current losses. Why? Armature core contains armature winding which deals with the AC current. So there are chance of having eddy current losses. To reduce eddy current losses, armature core should be laminated. Okay. And I told one more thing also. Just like a yoke or magnetic frame, armature core also carries 50% of the average value of flux per pole. So that was the conclusion about armature core. And if you see commutator, so what is the function of a commutator in a DC generator? It acts as mechanically rotating rectifier. In a DC motor, it acts as mechanical rotating inverter. And I told one important relation also, number of commutator segments will be equal to number of coils. Okay, and if just in the previous video I just drawn a commutator diagram also. So group of commutator segments can be called as a commutator. Commutator is a rotating part. It will be rotating. Okay, whenever your rotor is rotating, so commutator also will be rotating. But whereas brushes, which are simply placed on split rings or commutator segments or commutator, these brushes are fixed, they won't rotate. Whereas I can say commutator will be rotating. And just try to remember, guys. So number of commutator segments equals to number of coils. This was the relation I told in the previous video. In addition to these points, I told one more point. What is that? Commutator makes rotor MMF stationary with respect to, I can say, stator MMF. This was the point I had given in last. And I told in the next video I am just going to explain brushes and armature winding like that told. Okay, but see guys, before explaining brushes and armature winding, let me justify the point which I told last in a commutator. What is that? I told commutator makes a rotor MMF stationary with respect to stator MMF. This was the statement I told in a commutator. Some students are asking justification for that statement. So let me give justification for the statement in this video. So it also comes under construction of DC machine only. Okay. So let me justify the statement. First of all, let me write that statement on the board. What is that? Commutator makes rotor MMF, or I can say armature MMF also, because in DC machine we are placing armature winding on the rotor. So you can call a rotor MMF or you can say armature MMF also, no problem. Okay. So commutator makes rotor MMF stationary with respect to stator MMF. So stator MMF can also be called as field MMF. You know what is the reason? Because field winding is placed on the stator. Okay. So I am just going to give justification for this statement. Okay. So see guys, before that let me ask one simple question. In any rotating machine, if you see, so what are the conditions for production of torque? What are the conditions for production of torque? So that means I'm asking about electromagnetic torque. Okay. See guys, for production of electromagnetic torque, we need 2 fluxes, or I can say 2 mmfs we need. 2 mmfs we need. Example, if you see here, electromagnetic torque proportional to, I need 2 fluxes, or I can say I need 2 mmfs. Let me take in this example, I need a stator mmf and I need a rotor mmf. Okay. And second point, see, I am saying conditions for production of electromagnetic torque. Number 1, we need 2 fluxes, or I can say 2 mmfs. Yes, this is the first point. Second point, relative speed between 2 mmfs should be equal to 0. That means what? Suppose if you see guys, if it is a Fs is the mmf like this, I can say. Okay. And suppose if Fr is like this, rotor mmf is like this. Okay. So relative speed between stator mmf and rotor mmf is 0 means, so if example stator mmf is rotating with 1000 rpm, rotor mmf also should rotate with the same speed 1000 rpm in the same direction, just like stator mmf. Suppose if stator mmf is rotating with 500 rpm, rotor mmf also should be rotated with the same speed 500 rpm in the same direction. Suppose if a stator mmf speed is 0, rotor mmf also should be equal to, rotor mmf speed also should be equal to 0. That means, so speed should be equal and it should be in same direction. That is the meaning. I am saying the relative speed between the 2 mmf should be equal to 0 means, speed of stator mmf and rotor mmf will be same, should be same, and it should be a direction of Fs and Fr should be in the same direction. Okay, so then only relative speed becomes a 0. Okay, this is the second point. And what about third point? Though relative speed between 2 mmf should be equal to 0, but there should be some time displacement angle lambda between Fs and Fr. There should be some time displacement angle between Fs and Fr, nothing but lambda. Okay, that means Tm proportional to Fs Fr sin lambda is the relation we are having. So this is the relation for electromagnetic torque. So for production of electromagnetic torque we need 2 mmfs, and the relative speed between 2 mmf should be equal to 0, and there should be some time displacement angle between 2 mmfs. Okay, right guys, here the problem is, example, let us assume that in a DC machine guys, in DC machine, we are placing armature winding and the rotor. Rotor is the rotating part. Example, if a rotor is rotating with omega speed, example, if a rotor is rotating with the omega speed in the anti-clockwise direction. So here problem is, I told relative speed between 2 mmf should be equal to 0. Suppose in DC machine, if you rotate rotor with the omega speed, omega radians per second speed in anti-clockwise direction. Now you already know that in DC machine we are placing field winding and the stator. Stator is a stationary part. Okay, stator is a stationary part. So what is the speed of stator mmf? I can say 0. If it is 0, what I told previously, if speed of stator mmf is 0, speed of rotor mmf also should be equal to 0. Then only I can say that relative speed between 2 mmfs is 0 means, if this speed is 0, this speed also should be equal to 0. Okay, but here problem is rotor is rotating. That means rotor mmf also rotating. So now commutator will come into picture. Though rotor rotates, it makes rotor mmf stationary with respect to stator mmf. So commutator will come into picture. It makes armature mmf, nothing but because armature winding is placed on the rotor. So I can say rotor mmf, or I can say armature mmf also, no problem. So commutator makes armature mmf stationary with respect, I can say, field mmf, because field winding is placed on the stator. So that is the function of commutator. That only I am just going to justify in this video. Okay. See guys, commutator makes rotor mmf stationary with respect to stator mmf. That only we are going to discuss here. Okay. Right guys, now for explaining this, let me take 2 poles here. Let me take 2 poles, north pole and south pole. Let me take north pole like this, and yeah, please try to follow clearly, because after explaining, this figure becomes difficult for you. So that's the reason, please try to follow step by step. Okay, I'll give time, you please try to follow slowly. So let me have a rotor. Let me place rotor, and I told you will be having two poles, right? So I had taken north pole. Now let me take a south pole. South pole like this. North pole, south pole, and this is what I can say rotor. Okay, guys. Now guys, let me take, already I told in armature, generally armature winding will be placed on the rotor. So before that you will be having armature core will be there. In that armature core you have to provide some slots. In this explanation I am just going to take so 4 slots, okay. Let me take 4 slots here, guys. Let me take 4 slots here. Yeah. So I am just going very slow, no problem, because this topic will be, diagram will be somewhat difficult for you to understand. So that's the reason I am just going very slow. Okay. So slot number 1 and slot number 2. I am just taking here simple 4 slots. I am just taking here 4 slots. Right, guys. Right. Right. This is what I have taken. I have taken 4 slots here. Slot number 1, slot number 2, slot number 3. And slot number 4. I had taken 4 slots here. Okay, guys. Next, one more thing. See, in armature core we are having some slots. In these slots we have to place armature winding. So winding means generally we are having a single layer winding and double layer winding. In this discussion I am just going to take a double layer winding. Before that you should know the difference between single layer winding and double layer winding. This I already explained in a synchronous machine. Anyway, I am just repeating once again. Try to see here. Single layer winding. So single layer winding means, so example, let me take 4 slots here. 4 slots. I have taken 4 slots here. Okay. So before explaining single layer winding, double layer winding, guys, let me ask one simple question. Suppose if AB is a conductor, CD is a conductor, what about ABCD is a coil? No, I can call ABCD is a coil, right? ABCD is a coil. ABCD is a coil. Now please tell me, guys, in this coil I am having 2 coil sides. If you observe clearly, this is what one coil side, this is what another coil side. Okay, it's a single turn coil. In this single turn coil, it is a coil side and is also coil side. Okay, that means 2 coil sides gives you 1 coil. 2 coil sides gives you 1 coil. Okay, don't confuse with the coil sides and the coil. I said 2 coil sides gives you 1 coil. Okay. Now single layer winding definition means very simple. In the single layer winding, in each slot we have to place 1 coil side. Example, see. Suppose in this example, in this slot, I am just going to place 1 coil side here. Here another coil side. Here another coil side. Here another coil side. So if we place 1 coil side in each slot, that is nothing but single layer winding. Okay. Now tell me, guys, in this example, what are the number of slots? Number of slots is equal to how much? Please tell me. Number of slots, how many I have taken here? 4 slots I have taken, guys. Now what about number of coil sides, please? Number of coil sides I am saying. I am asking number of coil sides. Number of coil sides. I told you this becomes 1 coil side. Second one, third one, fourth one. So number of coil sides are 4, I can say. Now what about number of coils? So I told you 2 coil sides gives you 1 coil. That means number of coils is equals to number of coil sides by 2. Okay. Therefore number of coils is equals to how much? 2. So what is the relation between number of coils and number of slots ultimately here? Number of coils is equal to number of slots divided by 2. This is the relation for single layer winding. Is it clear, guys? Now what about double layer winding? double layer winding, let me take same example, double layer winding, let me take same example. How many number of slots I have taken? So 4 slots, 1, 2, 3, 4. Okay. So double layer winding means in each coil, in each slot, we are going to place 2 coil sides. 2 coil sides, one in top layer, another in the bottom layer. One in top layer, another in bottom layer, or I can say one in upper layer, another in lower layer. One in upper layer, second one in lower layer. Okay, lower layer, top layer, I can say bottom layer. So now tell me in this case, how many number of slots I have taken here? What are the number of slots? Here I have taken 4. What about coil sides, guys? Coil sides I am asking, coil sides. So this is one coil set, this is another coil set, this is another coil set, this is another coil set, like that. Please count. You are going to have 8 coil sides here. Now what about number of coils? Number of coils is equals to number of coil sides by 2, that becomes 8 by 2, it becomes how much here? 4. So ultimately, what is the relation between number of slots and number of coils in a double layer winding? So number of coils is equals to number of slots. Number of coils is equals to number of slots. This is relation for double layer winding. This we already explained it. Okay, this we already explained it in synchronous machine. I just repeated this one. Okay, so here coils equals to 8 by 2, 4. Number of coils is equals to number of slots. This is relation for double layer winding, and this is relation for single layer winding. Is it clear, guys? Now tell me. I said that in this example, I am just going to take a double layer winding. That means in each slot we have to place 2 coil sides, one in top layer, another in bottom layer. 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 Is it clear, guys? Okay. Now see, guys, you know already, always flux lines will start from north pole surface, it reaches towards south pole surface. You tell me, guys, here this is nothing but north pole surface. From here flux lines will start, it will go towards south pole surface like this. That everybody knows it. Okay, therefore let me indicate that arrow mark, direction of flux lines here. Because if I show here, it will be having some confusion for you, because in future diagram becomes complicated. That's why this direction of flux lines I just indicated instead of here, I just indicated here. Okay, this is what direction of flux density B. Okay, now please, guys, one more thing I am asking question, simple question I am asking. Let us assume that, let me move the rotor in anti-clockwise direction like this. With omega speed, I am just rotating rotor in anti-clockwise direction like this. Now tell me, by already we know that in DC machine, because of relative space variation, where conductors are moving, where magnetic field is time invariant, so dynamically induced EMF will be induced. We know already in DC machine we are placing field winding on the stator. To that field winding we are going to give DC supply. Nothing but DC supply means what? You will be getting a DC flux, or I can say time invariant flux. Whenever flux is magnetic field is time invariant, whenever conductors are moving, I can say that because of relative space variation, dynamically EMF will be induced, and direction of dynamically induced EMF is given by Fleming's right hand rule like this. See, in Fleming's right hand rule, the thumb indicates what here? When a moving conductor cuts the magnetic field, an EMF or current is induced in that conductor. Means thumb means direction of motion of the conductor, forefinger means direction of magnetic field, center or middle finger means direction of EMF or current induced. Now I am just going to decide what is the direction of EMF or current induced in slot number 1, slot number 2, slot number 3 and slot number 4. For that, what you should know, that means if you want to decide the center finger direction or middle finger direction, you should know the direction of thumb and forefinger. Forefinger means what? This one only, this arrow mark only. Direction of magnetic field already we got. And you should know the direction of thumb. Thumb means direction of motion of the conductor, direction of motion of armature winding, which is placed in the rotor. What the direction of rotation of rotor had taken? Anti-clockwise direction. Please try to take tangential motion of direction of conductor at slot 1, slot 4, slot 3, slot 2. Okay. See, for for anti-clockwise direction, so at 1, this is the direction of what? This is direction of velocity of the conductor, direction of motion of the conductor. Okay, with the linear velocity v, it is moving. Okay, and guys, direction of magnetic field means this one, yes, this one. Okay, yes. So you please tell me what might be the angle, almost an angle between this B and B, because it will be useful for us in future. Dynamic EMF formula, I told you, ED equals to, integral V cross B dot dl. Okay, so that I told ED equals to how much here? BLV sin theta. Here theta means what? That already told in the basics video only. Theta is the angle between V and capital B. Tell me what is almost all, it will be around 135 degrees like that. It's not, I'm assuming it's around 135 degrees. Please try to remember that. It will be useful for us in future. Okay, right. So now tell me guys, with this direction of magnetic flux density and with this direction of motion of the conductor, what might be the direction of current or EMF induced in this slot number 1? Please tell me. Apply Fleming's right hand rule, guys. Thumb, motion of the conductor. This means red color. When a moving conductor cuts the magnetic field, forefinger means direction of magnetic field, direction of flux density B, or I can say direction of this green color. Thumb means direction of this red color. So tell me what is the direction of center middle finger into the board. See, thumb is upwards here, forefinger is like this. So center finger is into the board. Into the board means what here? Direction of current entering into the board means cross. Let me take cross. So direction of EMF or current induced in slot number 1 is nothing but cross. Is it clear, guys? Now similarly, please tell me at a fourth slot. Okay. Once again, it is rotating in anti-clockwise direction. It is coming like this, and tell me at fourth slot, this is the direction of linear velocity. And what might be the direction of flux density? This one. So please apply. Okay. When a moving conductor, thumb means this, direction of this motion of the conductor. I can say direction of this red color arrow mark. When a moving conductor cuts the magnetic field, forefinger means direction of flux density, or I can say direction of this green color. EMF or current is induced in that conductor. Out of the board, this center finger is coming from the board. Coming from the board means what? You should take dot. Okay. So direction of current or EMF induced in slot number 4 is dot. Okay, guys. Once again, here also if you observe, it will be around 135 degrees only here also. Right. Next, once again, if we take anti-clockwise direction at slot 3, this is the direction of linear velocity of the conductor. And what about direction of flux density? It will be like this. Okay. Now tell me, when a moving conductor, this red color, when a moving conductor cuts the magnetic field, this green color. Okay, when a moving conductor cuts the magnetic field, an EMF or current is induced in that current. Out of the board, guys. Center finger means out of the board. Out of the board means what? Once again, dot. So let me take dot here. Now similarly, tell me at slot number 2, guys. Slot number 2. So once again, for anti-clockwise direction at slot number 2, this will be the direction of linear velocity. And already you know direction of flux density means from left to right like this. So tell me, when a moving conductor, this thumb indicates this red color, direction of motion of the conductor, cuts the magnetic field. Okay, the direction of this flux density or direction of green color. EMF or current is induced in that conductor. Once again into the board. Into the board means what? Cross. Okay, cross. So guys, for deciding this direction of current only, we have taken all those things. Okay. Now if we decided, then I'm just going to erase this portion. Okay. I'm just going to erase this portion. Yeah, please. So I think I can erase this direction of flux density, guys, and I can erase this direction of B and V here. Direction of V and B. I'm just going to erase this one. Here also erasing. Here also I'm just going to erase. Okay. All right. Right. Okay, right. Now tell me, let me ask one more question here. So this is the case. This is the case how EMF will be induced in slot number 1, slot number 2, slot number 3 and slot number 4. Okay. And guys, let me ask one question. So please, I will be placing commutator also on the rotor. Rotor is rotating part. So commutator also, it's a rotating portion. It is rotating part. Okay. Let me show commutator here. I am just showing commutator here, guys. I am just going very slow. Please don't confuse. Please try to see here, because slowly diagram becomes complicated. Then it becomes difficult for you to understand. Please try to follow slowly. If you are feeling difficulty, please try to press pause button and just try to draw up to this. Okay, right, guys. Now let me ask one question. How many number of commutator segments will be there? That I already told in the previous video. Number of commutator segments will be equal to how much? Number of coils. This relation I already told in the previous video. Please try to refer that. Now tell me, in this example, how many number of coils I had taken here? I am saying coils, not coil sides. Okay, coil sides are nothing but 8. Coils means 4 only. Okay, I should take here number of commutator segments is equal to 4. I should take here 4. Okay, let me take 4 segments. Yes, guys. Okay, let me give numbering also so that you will be having some clarity. Okay, segment number 1, guys. This one, segment number 1. Segment number 2, segment number 3, segment number 4. 1, 2, 3, 4. Okay, right. Next, let me ask one question here. So here I am just going to give connections. This you should be very careful with connections. Okay, please try to understand. See, guys, here if you take a fourth slot. Here in the fourth slot, as example, suppose if it is north pole is like this, south pole is like this. So always between north pole and south pole you are placing conductors, right? Okay, and already we discussed it. Here we will be having commutator. There is no need to repeat once again. Okay, so this in this coil, one end is nothing but this. I can say BC portion can be called as overhang. This we already explained in synchronous machine. Okay, so I am asking simple thing here. AB is a conductor, CD is a conductor, AB, CD is a coil, and this end connections can be called as overhang, and these ends should be connected to the commutator segments. Okay, commutator segments. That basics you should know. Then only you can understand clearly. Okay, see, guys, suppose if I take here AB conductor, let me take it as a fourth slot conductors. Okay, so fourth slot upper conductor, I can say. Here you are having upper conductor, lower conductor, no? So generally in double layer winding designing will be like this. In slot number 4, upper conductor is connected to here dot, no, leave one slot and just go to second slot. Okay, leave one slot and go to second slot. Upper conductor of a fourth slot is connected to lower conductor of slot 2. That means here it is a slot 2, here lower. Try to understand. So double layer winding design will be like this. Upper layer conductor of fourth slot will be connected to lower conductor of I can say slot 2. So like that you have to design. Okay, please let me give connections here. So fourth slot upper conductor means this one. Okay, and the second means here dot by here cross. You have to give connections from fourth slot, leave one slot and go to second slot. In this second slot, if I take here upper, you should take here lower. Okay, so here lower. So please give lower conductor connection in the form of dot, whereas upper conductor connection in the form of solid line. Okay, so right, next guys, similarly here I am saying From slot 1 upper conductor is connected to, leave one slot and just go to third slot. In third slot lower conductor is this one. So upper conductor is connected to, I can say, yes, connected to, okay, here third slot lower conductor, okay, you should give connections like this. So please try to show, okay, try to show in the form of dot line, okay, right. Okay guys, similarly, now let me proceed. I completed fourth one first, now next here, second slot upper connector is connected to fourth slot lower connector, okay, like this. Okay, here fourth slot lower connector. Next guys, third slot upper conductor is connected to first slot lower conductor, okay, like this. Should be very careful while drawing, okay. From third slot upper conductor is connected to slot number 1 lower conductor, okay. You can draw like this, no problem. This is third slot upper conductor, this is first slot lower conductor. Is it clear guys? So please try to complete, please try to press pause button and just try to complete connection like that, give connections like this, okay. And if you observe clearly, so whatever these lines are there, this one, whatever this coils are, this, if you take this one is ABCD is a coil guys. So this BC portion, whatever you are able to see, please try to see this BC portion, overhang portion. This BC portion is nothing but this one, this and this one and this one, okay, this one, these are nothing but I can say BC portions, okay. And tell me in coil, what is the other end? It will be connected to what? The other end is connected to what I can say? Commutator segments, no? Commutator segments. Now let me connect other ends to commutator segments. Okay guys, see, here you should be very careful guys. Fourth slot, I can say, fourth slot upper conductor is connected to, you can say, fourth segment, fourth commutator segment like this, and it is extended to, okay, it is extended to first slot lower conductor. Similarly, I can say here first slot upper conductor is connected to, I can say, commutator segment 1, okay, 1, and it is extended up to second slot lower conductor. Next, second slot upper conductor is connected to, I can say, second commutator segment, and it is extended to third slot lower conductor. Next guys, third slot upper conductor is connected to third commutator segment, and it is extended to fourth slot lower conductor, okay. Is it clear guys? Completed, okay. Now let me ask a simple question here, please try to be very careful guys. Here in this slot number 4, what is the direction of current? Dot means what? Direction of current coming from the board. From the board means this is the direction of current from the board. It is coming from the board. Arrow mark should be like this. Is it clear? And what about this cross? Cross means what? Entering into the board. Into the board means it is going towards this. It is going towards this slot. See, dot means out of the board. Cross means into the board. Arrow mark should be like this. Here arrow mark should be like this. Okay guys. Suppose if you apply KCL here, okay, if you apply KCL here, so it is coming here, it is leaving. Therefore, what is the current in this here? I can say 0 amperes. I can say 0 amperes. Similarly guys, please let me complete remaining portions here. Here if you see, yeah, this is the current regarding segment number 4, and let me decide current related to segment number 1. See guys, here dot is there, cross is there. Cross means what? Direction of current entering into the board, no? Into the board means what? It should be like this. Arrow mark should be like this. And here, once again a cross into the board means it should be like this. Suppose if I take this one as I amperes, if I take once again here I amperes, now what about this current? 2I amperes. Is it clear? Yes or no? 2I amperes. This is the current from segment number 1. This is the current from segment number 4. Now let me decide current from segment number 2, guys. Here cross means entering into the board. Yes, arrow mark should be like this. Here dot coming from the board. That means it should be like this. Okay. Now what about current here? Tell me. I'm saying a simple question. What about this current? This one 0 amperes, right? 0 amperes, because it is coming, it is going like this. So I don't have any current in from segment 2. Okay. Now let me decide regarding segment number 3. Here dot means current coming from the board. From the board means it should be like this. Arrow should be like this. Here once again what? Dot coming, direction of current coming from the board. From the board means what? It is coming from the board means arrow should be like this. Okay. Try to understand. Here dot means direction of current coming from the board. From the board is coming from the board, arrow mark should be like this. Here also direction of current coming from the board, arrow mark should be like this. Suppose if it is I ampere, guys, if it is I ampere, what about here current? 2I amperes, 2I amperes, 2I amperes. Okay. Now please let me show brushes also here. Do you have any current from segment number 4? No. Do you have any current from segment number 2? No. Therefore there is no need to connect brushes here, guys. Do you have any current from segment number of 1? Yes, 2 amperes is the current. Let me show brush like this. Let me show brush like this. Okay. And what is the do you have any current from segment number 3? Yes. So let me show once again like this. Okay. Yes. Now guys, suppose here 2I is the current coming from the brush. This is nothing but 2I amperes. And here 2I is leaving here, that means 2I amperes will enter brush. Okay, that's that means direction of direction of current will be like this in brush number. I can give numbering also, brush number 1, and you can give here brush number 2. Okay, this is the thing. Okay, now guys, let me ask focus our main heading. Okay, here thing, please let me draw once again this figure in a simple way like this. There is no need to show this one also. Simply I can take this arrow mark. Okay, this rotor position. The rotor position. If you want, I can show this one also. Even north pole, south pole also. If you want, you can show. No problem. Okay. This is the rotor position, and let me show one slot number 1, 2, 3, 4. Slot number 1, 2, 3, 4. Please try to show here. You should be having patience because this topic simple statement is very simple. Suppose if I say simply commutator makes rotor MMF stationary with respect to stator MMF, that is enough. But suppose if you want justification for that statement, so this much we have to discuss. Okay, no problem. So but try to have some patience. Suppose if you practice once or twice, it will be easy for you. Okay, no problem. Right. Yeah. Right. Let me give numbering also, guys. Slot number 1, 1. Slot number 2, 2. Slot number 3, 3. Slot number 4. Okay. Now please tell me what is the direction of current in slot number 1 you got cross. Actually I'm just drawing separately means if I show here only it will be having some difficult for you to understand. That's why I'm just drawing separately once again. Here in slot number 2, guys, once again cross. Slot number 3 dot. Slot number 4 once again dot. Okay, guys. Now this is nothing but I can say this is nothing but armature winding which is placed on the rotor. Okay. So before that, okay, let me ask one simple question. Suppose Can you please tell me what might be the direction of MMF? Which MMF I am saying? Let me ask F24, I can say F24. F24 means this one. See, from 2 here, winding actually going like this. Is cross is direction of current entering into the board. Dot means coming from the board. Cross, dot. From 2 to 4, coil is going like this. Okay. So current direction of current entering into the board, coming from the board. So tell me what might be the direction of MMF? Nothing but F24. It should be like this, no? That means this is what I can say MMF. Please try to understand. F24 will be like this. From slot number 2, if you see slot number 2 and slot number 4, here slot number 2 direction of current is coming into the board, slot number 4 direction of current coming from the board, so arrow mark will be like this. This is what I can say MMF. Nothing but F24 is like this. F24 is like this. Okay, right guys. Now please tell me, and what about I am asking MMF due to slot 1 and slot 3 I am saying. Slot 1 entering, slot 3 leaving. Once again direction of MMF will be like this, no? Like this. So let me show this portion MMF due to slot number 1 and slot number 3. I can show like this. This is what I can say F13. Okay. And this angle will be 90 degrees. Between F13 and F24 angle will be 90 degrees. Okay. Now guys, I am asking simple question. What is the resultant MMF due to rotor? I can say I am asking what is the resultant rotor MMF? Means vector sum of this F13 and F24, no? That's it. So let me show guys once again here for your understanding point of view. This F24 I am just showing here. F24 I am just showing here. F24 I am just showing here. Next F13 I am just showing here. F13 I am just showing here. F13. Okay. And vector sum of this F13 and F24 gives you what? Resultant MMF I can say. Yes. Vector sum to this F13 if I add F24, or to this F24 if I add F13, you are going to have resultant MMF in this direction. Okay, it is vertically F resultant MMF will be like this. Okay, or if you want me to draw, I will use some different color for this. For resultant MMF rotor MMF vector, let me use different color. This is what I can say FR guys. FR is like this. Okay, is it clear? So I am asking one question now. So what is the resultant MMF value? Resultant MMF value is equals to FR equals to, okay, so please tell me. So what is the angle between this F13 and F24? I told this is 90 degrees, right? 90 degrees. So tell me resultant MMF is square root of F13 square plus F24 square. Is it clear? So you should now tell me what is the value of F13 and F24. You are just going to tell me value of F13 and F24. Okay. So for finding this value, I am just doing here. So I am just going to erase all those things. Okay. Please let me erase all those things. Tell me guys, MMF. What is the formula for I can say MMF? Number of turns into current, no? Number of turns into current. That means MMF indirectly depends on current. So current depends on voltage. Current depends on voltage. If you take in slot number 1, slot number 4 or whatever. So I already told previously that direction of magnetic flux density is in this manner. And if you take here direction of most of the conductor slot number 1, it will be in this manner, no? This is our direction of velocity, and I told this direction of magnetic flux density. Okay, I think before I told you the angle between around 135 degrees, something like that. Okay, so here this is what I can say direction of linear velocity V, angle will be around how much here? I said 135 degrees. So you know guys, what is the formula for dynamic EMF ED integral V bar cross B bar dot DL bar. Now I think I told you ED equals, what is the formula I told? BLV sin theta. BLV sin theta. So tell me, here I told already angle between B and V is nothing but theta only. So tell me what about this value? ED equals how much I got? BLV sin 135 degrees. So I can write ED equals to BLV by root 2. BLV can be written as E max. This is the value of E max, right? Because if you see sin 90, if theta is 90 degrees, at that time ED value, max value, how much? BLV only. Therefore, BLV can be written as E max value, no problem. E max by root 2. If ED is E max by root 2, guys, what about current value also? I will be I max by root 2. I max by root 2. And what about MMF also? F max by root 2. F max by root 2. That means we are able to say the value, value of F24 means F max by root 2. Similarly, value for F13 also F max by root 2. So now tell me here, square root of F max by root 2 whole square plus F max by root 2 whole square. What about this value, guys? I can say F max is the value. Resultant rotor MMF is equals to how much? F max is the value. Is it clear? Okay. So please let me erase this portion. Okay. Right, guys. Right. Now my question. Suppose ultimately what we want to show here, commutator makes rotor MMF stationary with respect to stator MMF. That we have to discuss, right? That means what is the meaning? You know already, if you observe clearly here in this case, resultant MMF we are getting in this manner. This is what I can say, resultant MMF FR value. What about this value? I am getting F max. So resultant MMF we are getting like this. Vertically, that means like this. FR is resultant rotor MMF is nothing but F max you are getting. Okay. And what about resultant stator MMF? From north to south only, no? Yes or no? We are placing field winding in the stator. So field MMF or stator MMF is what? This, like this only, no? Like this only. This means like along D axis. D axis means what? Axis which is passing along poles. So this axis can be called D axis, guys. If you want, I can write here. See, this axis is nothing but which axis? D axis. What is the other name for D axis? Direct axis. What is the other name for direct axis? I can say polar axis. Polar axis. Axis which is passing along poles is nothing but polar axis or direct axis, or I can say D axis. Between poles, the axis which is passing between poles is nothing but what? Which axis? Interpolar axis. Interpolar axis. Or I can say quadrature axis. Quadrature axis. Or I can say Q axis. Q axis. See, some reason is there why I am writing all those things here. The reason is very simple. See, tell me by seeing this figure, guys, tell me where brushes are placed. That is a very important question. Tell me where brushes are placed, whether it is along D axis or along Q axis. Please try to see whether it is along D axis or Q axis. These are the brushes, no, B1, B2. Brushes are placed along D axis, G axis, D axis. Okay. So practically brushes will be placed along direct axis only, along polar axis only, along D axis only. But if you observe, generally we will be seeing a figure like this. Example, if you take armature, I will be showing brushes like this, and this is what I can say North Pole, and this is what I can say South Pole. North Pole, South Pole. What about this axis, guys? This axis. What about this axis? Direct axis, no? And what about this axis? Okay, Q axis, no? Q axis. So generally we will be representing brushes placed along the Q axis. Okay. Okay, that is actually not exactly, because practically we are placing brushes along the direct axis only. But generally why I am showing this brushes along the Q axis means, see in this figure, can you able to see commutator here? No. Since the commutator is not shown, for simplicity we can show this brushes along q axis. Is it clear? But here if a commutator is shown, definitely brushes should be placed along the d axis only. That point also please try to note down. Please note down one point. Practically anyway, regarding this we'll discuss clearly in next video, where we'll be discussing about brushes. Okay, just simply note down one point. Practically brushes are placed along direct axis. Practically brushes are placed along direct axis. Practically brushes are placed along direct axis, comma, but in general, since commutator is not shown, brushes will be shown along q axis. Brushes will be shown along q axis. Okay, this is it. Now tell me guys, now let me proceed our topic guys. Now what is the resultant rotor mmf? Vertical direction, like this. Okay, fr is, what is the value of fr? F max. Tell me what is the direction of stator mmf, or I can say field mmf, this one, because we are placing field along we are placing field winding in the stator, nothing but d axis. This is what I can say stator mmf. See, this is what I can say stator mmf value. Okay, so what is the angle between stator mmf and the rotor mmf here guys? 90 degrees. Okay, so you mean to say that here we are getting lambda value how much here? 90 degrees. Okay, and suppose if you observe clearly, I am just going to give justification for this statement. For that you do one thing. In this case, in this situation, okay, what is the resultant rotor mmf in this case, in this example? F max. Okay, let me shift by some angle. Let me rotate the rotor by some angle. At that time also, if you are getting same magnitude and if you are getting same angle between fr and fs, that means indirectly fr will be in stationary with the fs. That is the conclusion. Is it clear? So for that, let me move the conductor, let me move the rotor by 45 degrees. Okay, I can write here, if rotor rotates in which direction? Anti-clockwise direction by 45 degrees, then let us see what will happen. Okay, this is the situation. Now let us see what will happen in this case. 45 degrees means guys, so first of all let me show pose, after that I will show all those things. Yes, north pole, yes, and south pole. Before that let me show rotor, and let me show here south pole. Okay guys, the north pole and south pole. Okay, so here please try to be careful. Here 45 degrees means if your rotor is rotating by 45 degrees, this slot number 1 will come this side. This slot number 1 will come to this position. Slot number 2 will come to this position. Like that you have to shift by 45 degrees. That means if by after shifting by 45 degrees, slot number 1 will come here. Please try to think clearly. Slot number 1 will come this side and slot number 2 will come this side. And what about slot number 1, slot number 2 guys? Slot number 1 is going this side, slot number 2 is coming this side, slot number 3 is coming this side. Okay, slot number 3. And what about slot number 4? It is slot number 4 is coming this side. Okay, This is the situation after shifting by 45 degrees. Okay, 45 degrees. 1, 2, 3, first slot, second slot, third slot, and fourth slot. Okay, right, guys. Now, as usual, you know what is the direction of rotation of rotor? Anti-clockwise direction. So please, anti-clockwise rotation, omega. Okay, omega. Now, yes. Now please try to see for anti-clockwise rotation what. Okay, before that, guys, please let me show double layer winding. No, let me show 2 coil sets in each slot. Okay, don't forget about that. So in slot number 1, let me show 2 coil sets here. In slot number 2 also 2 coil sets. Slot number 3 also 2 coil sets. Slot number 4 also 2 coil sets. One in the top layer, one in the bottom layer, or I guess one in upper layer, another one in lower layer. Okay. So guys, now, so already you know the direction of flux density. Always flux lines will be going from north pole surface towards south pole surface. No. Yes, it is going in this this direction of flux density. B is the flux density direction. Now tell me at slot number 1, what is the tangential motion of direction of conductor? Slot number 1 means it is coming like this, like this, like this, like this. At slot number 1, tangential motion will be like this. No, this is direction of motion of the conductor with a linear velocity v. And tell me, guys, you already know direction of flux density means what? At this position, like this B value. We know ED formula, dynamic induced EMF formula, BLV sin theta. If theta is 180 degrees angle, what about this angle? Theta is the angle between small v and capital B. If it is 180 degrees, what about ED value? 0. 0. There is no EMF in slot number 1. Similarly, no EMF slot number 3 also. If you want, you can check. Okay. So anti-clockwise rotation like this. Yes, it is coming at tangential motion at slot number 1 is like this. At tangential motion at slot number 4 is like this. Tangential motion at slot number 3 is like this. Tangential motion at slot number 2 is like this. Okay, guys. Now please let me check in slot number 3. Direction of flux density is in this manner. What is the angle between V and B? 0 degrees. They are in parallel. So obviously, what about ED value? 0. Therefore, there is no EMF in slot number 1 and slot number 3. Leave it. Okay. And let me focus on slot number 2 and slot number 4. For that, you know, only direction of flux density is in this manner. No. Okay. And here also in this manner. Let me decide. So at slot number 2, guys, use Fleming's right hand rule and tell me direction of EMF induced in slot number 2. When a moving conductor upwards, direction of motion of the conductor, this is red color indicates thumb. When a moving conductor curves the magnetic field, this green color indicates forefinger. When a moving conductor curves the magnetic field, an EMF or current is induced in that conductor into the board. Into the board means what? Cross. You should show. You should show cross. Similarly, at slot number 4, guys, tell me, when a moving conductor, thumb means direction of motion of the conductor, direction of this red color, direction of V. When a moving conductor cuts the magnetic field, forefinger means direction of this capital B, direction of, I can say, green color. So when a moving conductor cuts the magnetic field, an EMF is induced in that conductor. So direction of center finger or middle finger means what? Out of the board, coming from the board. Coming from the board means what? Dot. Let me show dot here. Okay, guys. So for deciding this direction of EMF only, I had taken all those things. Now after deciding, let me erase all those things. Okay, right? We don't want V, B, all those things. We need V and B direction for knowing the direction of EMF. We already decided, right? Now let me erase all those things so that we will get some space here. Okay, right, guys. Now as usual, after discussing so before that, what I told, let me give connections also. So those who did not follow clearly here, I am just going to explain once again. You please try to at least now follow. Okay, so what I said, guys, so from slot number if you see, so what I said, from slot number 4, I told you slot number 4 upper conductor is going on connection with and it will be connected with second slot lower conductor. Okay, let me complete this. So fourth slot Okay, fourth slot upper conductor is connected to whom here? Connected to whom? Second slot lower conductor. Let me use dotted lines for this. Okay, I am just going to erase this portion also, so that we will get some space here. Alright. Next, slot number 1 upper conductor is connected to whom here? Okay, it is connected to third slot lower conductor. Okay, it will be like this. Lower, no? Okay, similarly, next here, second slot upper conductor is connected to whom here? Fourth slot lower conductor. Okay, so we will be giving connection like this. Okay. Similarly, third slot upper conductor is connected to first slot lower. Okay, right, this is the thing. Now let me show your commutator also here. Commutator, please let me show commutator here. I already told you commutator will be placed on the rotor, no? Sir, no? Rotor. Right. Right. So guys, observe clearly here, whenever rotor rotates, commutator segments will be rotating, whereas brushes will be fixed. If you observe clearly, it is rotating by 45 degrees in anti-clockwise direction. So segment 1 will come this side, segment 2 this side, segment number 3, segment number 4 like this. They will be rotating anti-clockwise. But don't say that brushes will be rotating. Brushes will not rotate. Brushes will not rotate. They will be simply placed on the commutator segment. They are fixed. They are fixed. Okay. So now let me show segments also here. Before that, try to see this one. Yeah. Initially, observe clearly, segment number 1 is here, no? If a rotor is rotating anti-clockwise direction, segment number 1 will go somewhat upside. That means this becomes segment number 1 now. So let me use same color. What I just indicated blue color. Let me indicate blue color 1, 2, 3, and 4. Very simple. If commutator segment is rotating anti-clockwise direction, this segment number 1 will go somewhat 45 degrees upwards. Yes. Next segment number 2 45 degrees upwards. It is initially here no, segment number 2 is here. Now it will go like 45 degrees in anti-clockwise direction. Okay. Next segment number 3 also, it will come in anti-clockwise direction by 45 degrees. Similarly, segment number 4 also will rotate in anti-clockwise direction by 45 degrees. Is it clear? Right. Now guys, observe. Please try to see here. Yeah, and one more thing I told. So I told you, if you take a coil, so overhang portion is nothing but this portion. Overhang means this portions or whatever you are able to see, this red color, this is the overhang portion. This portion, don't confuse. Overhang means this one. If you take A, B, C, D conductor, so this BC is the overhang portion. This only you are able to see in this red color. Okay, and other end I told you it will be in connection with what exists segments, commutator segments, right? Yes or no? So let me connect coils to commutator segments now. Okay, very simple. I already explained here. Same thing, I'm just repeating here. Fourth slot upper conductor will be connected to fourth segment. Okay, and it will be extended to first slot lower conductor. Is it clear, guys? Next, first slot upper conductor will be connected to first segment, and it will be extended to second slot lower conductor. Next, second slot upper conductor is connected to segment number 2, okay, and it will be extended to third slot lower conductor. Okay, and third slot upper conductor is connected to whom here? Third segment, and it is extended to fourth slot lower conductor. Is it clear, guys? So now please tell me direction of current from into the segments, guys. Very simple. Do we have any current from this slot 1? No. And what about this? If you see slot number 2, guys, we are getting cross. Cross means what? Direction of current entering into the board. Into the board means arrow mark should be like this. into the board. Okay, not coming from the board, it is into the board, means arrow mark should be like this. Okay, so this is what I can say, I value. Okay, I value. So do you have any current here? No, 0 amperes. So obviously total current will be coming from the segment number 1, I amperes. Here I can say 0 amperes, there is no need to show 0 amperes here. Okay, now guys, now what about this one? If you see, if it is segment number 2 guys, here getting cross. Cross means direction of current entering into the board. Into the board means arrow mark should be like this. Do you have any current in this slot number 3? No. Therefore, obviously this current will be coming from the segment number 2 only. I amperes. Once again, I amperes here. Now, do you have any current from this slot number 3? No. And do you have any current from this slot number 4? I can say yes. Dot. Dot means coming from the board. Therefore, arrow mark should be like this. I value should be like this. So since we don't have any current in this slot, so this enter current will be coming like this only. And let me take segment number 4. So do you have any current from this slot number 4? Yes, dot coming from the board. Coming from the board means arrow mark will be like this. And do you have any current in slot number 1? No. Therefore, what about here direction of current in slot, I mean segment number 4, it will be like this. Okay. Now guys, observe guys, very simple. I am just going to explain clearly. See, initially this entire brush is connected to whom here? This entire brush is connected to, I can say, entire brush is connected to segment number 1 here. Okay, is it clear? Now suppose if you rotate by 45 degrees, now it will be in connection with 1 and 2. See, don't confuse. Say brushes are not rotating. Brushes are not rotating, I am saying. Okay, brushes are not rotating. Segments are moving. Whenever brush B2 is here, initially, so let us assume that initially brush B2 is here, segment number 1 is connected. Now segment number 1 is moving, whereas brush is stationary only. Segment number 1 is moving means, so some portion of segment number 1 will be connected to brush, and here from this segment number 2 also coming, no? So some portion of segment number 2 also connected. So now what I am saying is, yes, brush B1, B2 I can say. B2 initially is connected to segment number 1. Now B2 will be connected to segment number 1 and segment number 2 like this. Once again I am saying guys, here brushes are not moving. Segments are moving. Initially segment number 1 is connected to brush B2. Now segments are moving in anti-clockwise direction by 45 degrees. So segment number 1 and segment number 2 will be connected to brush 2 here. Okay, right? I can give a name also, brush 2, brush 2. Now similarly here also, see, initially brush 1 is connected to segment number 3. Now because of anti-clockwise rotation, now brush B1 will be connected to not only segment number 3 but also to, I can say, segment number 4 also. Now brush B1 will be in contact with I can say third segment and the fourth segment. Is it clear guys? Right, completed. Now let me decide direction of current here. Okay, tell me guys, see, from this brush B1, tell me what is the total current from this brush B1, please tell me. It is connected to segment number 4 and segment number 3 I said. So from, see, current entering into the segment number 3, I amperes. Current entering in segment number 4, I amperes. What is the total current? 2 I amperes. 2 I amperes. 2 I amperes. So from this, 2 I amperes will be coming here. 2 I amperes will be coming. Similarly, see, if you see here, segment number, brush number 2 is connected to segment number 1 and 2. So from segment number 2, I ampere is going. From segment number 1, I ampere is going. So what is total current here? 2 amperes. 2 amperes is going. So direction of current will be like this. See, from brush number 1 is a downward arrow mark 2I. Brush number 2, upward arrow mark 2I. Is it clear guys? Is it clear? Right. So now tell me, I am going to decide ultimately this portion. Just for this diagram I have taken this one. Similarly for this diagram, just let me take another figure here. But there is no need to show slot number 1 and slot number 3 guys. What is the reason? Slot number 1, slot number 3, there is no current. Therefore there is no need to show slot number 1 and slot number 3. Let me show slot number 2 and slot number 4. That's enough. Okay. So simple. Just we are going to complete the topic. Just try to see here. I'm just going to conclude here. See, slot number 2 is this one. Yes, slot number 4 is this one. Okay. Please indicate slot number 2, slot number 4. Here, what is the direction of current in slot number 2, guys? I can say cross, here also cross. Direction of current in slot number 4, dot, here also dot. Okay, guys. Now tell me, what is the direction of current? Sorry, I can say what is the direction of flux due to slot number 1 and slot number 2 and slot number 4? Apply right hand thumb rule. That's it. See. Here slot number 2 current is entering, slot number 4 current is leaving. Entering, leaving. Entering, leaving means what? Direction of flux? Upwards. Direction of MMF? Upwards. So simply I can say direction of rotor MMF will be upwards like this. FR is in this manner. FR is in this manner. Okay? Is it clear, guys? Now, please tell me, I am going to ask one simple question. You previously told FR equals F max, no? And you told angle between FR and FS is 90 degrees. Here also very simple. See, what about this FS value? It is along north pole and south pole. Here also along north pole and south pole. So once again, just like this one, FR is here, okay, and along x-axis, FS is in this manner. So what is the angle between these two, guys? 90 degrees only. See, initially 90 degrees, now also 90 degrees. Initially, what is the magnitude of FR? F max. Now let me decide magnitude of FR. Here magnitude of FR. If you are getting same value just like F max, then we can say that yes, your rotor MMF, okay, is stationary with respect to stator MMF. See, previously FR, what is the magnitude of FR? F max. Now also if you are getting same value, okay, that means magnitude is same, and previously angle between Fs and Fr 90 degrees. If you are getting same angle now also, that means what is the meaning? So rotor MMF will be stationary with the stator MMF. That is the only meaning. No? Now please tell me, how can you find out the FR value here? I am asking rotor MMF value. Very simple. See, guys, previously what is the angle between V and B here? 130 degrees. After rotating by 45 degrees, guys, if you see slot number 2 or slot number 4, if you want, you can check here. For anti-clockwise rotation, I told in slot number 2, this is the direction of velocity, okay, or slot number 2, tangential motion will be upwards. And what is the direction of flux density? Like this. Okay, is it clear? Now tell me, what about ED value? BLV sin theta. Okay, ED value. BLV sin theta, 90 degrees, no, angle between V and B is 90 degrees here. So sin 90, I can say, what about this value? BLV. I already told BLV means E max, E max. If ED is B max, what about I value also? I max. If I is I max, what about F also? F max. F also how much here? F max. Is it clear? Okay. Yes or no? F max. So simply I can say that here we are having only, previously we are having F13 is there, F24 is there. F13, F24. F13 value I got how much? F max by root 2. F24 value how much I got? F max by root 2. Vector sum of these two gives you F max. But here we are getting only one MMF only, no, because there is no EMF in slot number 1 and slot number 3. So simply F value I got F max, that means FR value how much here? Ultimately F max. Here also F max, F max. Is it clear? So now let me conclude. So what is our whatever I just made discussion here, the only thing here is I am just going to justify this statement. Commutator makes rotor MMF stationary with respect to stator MMF. For that, if you take this relation, Tm proportional to Fs Fr sin delta. For production of torque, we need to mmf. Yes, Fs is mmf, Fr is mmf, and there should be some angle between Fs and Fr. Lambda should be there. Okay. Suppose if Fs speed is 1000 rpm, Fr speed also should be 1000 rpm in the same direction. Then only torque will produce. I told now. For what are the conditions for production of torque? I need two fluxes. The relative speed between two fluxes should be equal to 0, and there should be some time displacement angle between Fs and Fr, lambda value. Now, in this case, in our example in DC machine, what is the speed of Fs? So, field when is placed on the stator, it is a stationary portion. So, Fs is nothing but fixed. Okay, it won't move. Okay, Fs speed is 0 rpm. Since speed of Fs is 0 rpm, okay, so Fr also should be equal to 0 rpm. But problem is, generally people will think like this, sir, we are placing armature winding in the rotor is moving, therefore Fr also will be moving. No, like that people will be thinking. For that only commutator is there. Commutator makes rotor mmf stationary with respect to stator mmf. If stator mmf speed is 0 rpm, it makes rotor mmf speed also 0 rpm. So that only we justified here. How? Initially, if you take, in this case, I got Fr value F max, and if you see here, angle between Fr and Fs is 90 degrees here. If you shift by 45 degrees, then also we are getting Fr value F max only. There is no change in magnitude. And if you see, what is the angle between Fr and Fs value? Once again 90 degrees only. Is it clear? That means indirectly, Fr is stationary with Fs. Okay, so there is a conclusion, very simple conclusion. So if you see, already previously I just drawn on figure. If Fs is like this, if Fr is like this angle delta value is the angle between Fs and Fr. Suppose if you rotate rotor in anti-clockwise rotation by omega speed, with omega speed, generally what people will think, see I am repeating very slowly. See, we are placing field winding in the stator mmf is Fs, let us assume that, and we are placing armature winding in the rotor. So Fr is the mmf of rotor. I told you production, what are the conditions for production of torque means we need two fluxes, two mmfs. Yes, I got, and relative speed between two mmf should be equal to 0. Okay, and there should be some time displacement angle alpha between Fs and Fr. But problem here is, so many people will be thinking like this, sir, we are placing armature winding in the rotor, so rotor is rotating part, rotor is rotating, therefore Fr also will be rotating. At that time lambda may change, like that people will think. You are getting my question? If Fr rotates in anti-clockwise rotation, in anti-clockwise direction by omega speed, with omega speed, people will think like this. So angle between Fs and Fr initially is lambda, sir. Since armature winding is placed in the rotor, if rotor rotates by 45 degrees or something angle with some speed, people may think that, so angle between Fs and Fr may change. So here my question is, I am just going to justify, it won't change, angle will not change. So angle will not change, that function is carried out by a commutator. So for that I have taken this example. If you want, you can check here. Fr is initial, it is here, Fs is here. What is the angle between Fr and Fs? 90 degrees. This 90 degrees only we are taking it as lambda. Suppose if you rotate by 45 degrees, okay, now in this case, what is the Fr value? Once again F max. And what is the Fs value is like this. What is the angle here? 90 degrees. So which is equal to how much? Lambda. Tell me, do we have any change in the lambda angle here? No. That means what is the meaning? That means commutator will come into picture. It makes rotor mmf stationary with respect to stator mmf. Okay, if stator mmf speed is some 1000 rpm, it makes rotor mmf also, it rotates rotor mmf also with 1000 rpm in the same direction. If stator mmf speed is 550 rpm like that, or 500 rpm, commutator rotates rotor mmf also with the same speed 500 rpm in the same direction. But here, what about speed of Fs? 0 rpm. because we are placing field winding in the stator, which is fixed. Stator is a stationary portion. It won't rotate. Therefore, what is the speed of a stator MMF? 0. So, ultimately, what is the function of commutator? Commutator has to come and it should make rotor MMF stationary with respect to stator MMF. Initially, if you see in this case, F1 is here, Fs is here. This angle, lambda 90 degrees angle. After 45 degrees also, Fs is here, Fr is here only. Do you have any change in angle? No. That means what is the conclusion? Commutator makes rotor MMF stationary in space, or I can say commutator makes rotor MMF stationary with respect to stator MMF. This is the conclusion I can give. Okay, this point I had given in the last video, but I am just going to give justification in this video. Okay, next guys, in the next video I'll be discussing about brushes and armature winding, and we'll proceed. Okay, and in this entire portion, so this is justification. This much is not necessary for GATE and ES examination, but knowledge point of you should understand all those things. Otherwise, they won't ask you to design in the GATE examination or something like that. Okay, they won't ask. Okay, simply you have to remember this point. Commutator function, in DC generator it acts as mechanical rotating rectifier. In a DC motor it acts as mechanical rotating inverter. And what is the other function? Commutator makes rotor MMF stationary with respect to stator MMF. And one more point I told, what is that? So we have to place brushes along which axis? D axis. But generally, since the commutator is not shown, we will be representing brushes along the Q axis. But practically brushes are placed along which axis? It is placed along D axis only. Okay. Next, in the next video guys, I will be discussing about brushes and armature winding. Please try to draw all those things. Thank you.